Hi you guys, Mrs. Snyder here. I just want to do a quick video of this simulation of what happens when something dissolves in water. And there's two things that you have to really consider. You have to think, is it an ionic compound? Because it's going to do something different than what a covalent compound will do. And I think if you've read through the first part of the page on our lesson, you kind of can understand that there's a difference between being an ionic compound and a covalent compound. So what I've got is the sim here. I'm just going to shake some salt in here, and this is sodium chloride, and you'll notice that it breaks up into a sodium ion and a chloride ion. And there's something very unique that's happening here, is that we say that we have one part of sodium chloride, but then they break up, as you can see here in this bar graph up here, by a sodium ion and a chloride ion. And what you will also notice is, I'm going to turn to the water animation here. When I put a crystal of sodium chloride into the water, notice that the sodium chloride breaks up. I'm going to pause the animation here. I'm hoping to. And maybe it's not going to pause, but there is a really unique way that the sodium ion has the water around it and the chloride ion has the water around it. Since the chloride ion is negatively charged, you'll notice that, here we're going to redo this again and I'm going to show you, the chloride ion is negatively charged. So that means the positive side of the water is around the chloride ion, whereas the sodium ion is positively charged. So the negative side of the water molecule, the oxygen side. So that is very unique when we are dissolving ionic compounds. Okay, what's it going to look like? Here, I'm going to reset. What's it going to look like if we put sucrose in here? Okay, so sucrose is made up of carbon, hydrogen, and oxygen. It's a disaccharide, and this is actually a picture of what sucrose looks like. And the carbon, the hydrogen, and the oxygen, when we put those in here, they do not break up. They stay together as one big clump. That's because it's an ionic compound. And that's the difference of what happens in the dissolving process. Ionic compounds are going to break up. Covalent compounds dissolve, but they stay together. All right, the next thing I want to do is just look at, what if we changed and compared the solutes of two different ionic compounds? This is where something very interesting happens. So here's sodium chloride. We're going to take that a look again. And you notice that you break up into sodium ions and chloride ions, right? Okay, that makes sense. There's one sodium ion for every one chloride ion. But look what happens when we do something like calcium chloride, which has two chloride ions for every one calcium ion. When I shake this into the water, and now I'm going to look at my bar graph here, notice that the chloride ion concentration is twice that of the calcium ion concentration. That is because the chloride ion concentration is doubled by the formula here. So it has to do with electronic structure as well. Just because it's fun, we're going to looking at something like sodium chloride again. So here's my sodium chloride, which is that 1-to-1 ratio, right? One sodium for every one chlorine. And now we're going to look at what it looks like with sodium nitrate. Now notice that sodium nitrate, even though there's 3 oxygens here, remember this is a polyatomic, so it stays together. So as one unit. So I'm going to shake some sodium nitrate in here, and that ratio is actually 1-to-1 as well. Notice that nitrate ion is acting like a polyatomic and it's staying together. Okay, so that is kind of just a real quick little rundown of what happens with the dissociation of ionic compounds versus sugar compounds. Again, here's the picture of what happens with an ionic compound. It breaks up. But notice when I put the sugar in here, the sugar actually stays together as one clump. That's because it dissolves, because we know sugar dissolves in water, but it does actually, the bonding between the carbons and the hydrogens and the oxygens, they all stay together. Hope this helps.